Hello there. So today we are in the geometry class. They're going to say hello. Hi. There you go. Okay. And we know that some of you are off doing recruiting for our school at Hemet something. So I hope you're having a blast. But you have not gotten out of doing your homework because, as you can see, we have a video for you to show you how to do tangent, sine, and cosine. I also wanted to mention in my video that from now on, you will be able to use your notebook on your quizzes. That's what I said, right, class?
Yes.
So, just to encourage you to take good notes starting today, so that when you have your next quiz over 9.1 and 9.2, you will be able to use your notes on your quiz. So, take some good notes. All right. So, first thing I want to do here is talk to you a little bit about the anatomy of a right triangle. And we have two options here. So, we have two right triangles. We have the 90-degree angle marked. And the hypotenuse is always opposite the 90-degree angle. Always, always. However, the adjacent side and the opposite side kind of depend on which angle you're talking about. If I am focused on this angle up here, which I'm going to call theta, and that's a Greek letter, do not be scared. It's just a Greek letter. Okay? Like T, but no, theta. Okay? So there's my variable. And this side is touching, so that's the adjacent side. And then this side is opposite. But if I choose to focus on a different angle, like what if I move theta down here, then that kind of changes the adjacent and the opposite side. It doesn't change the hypotenuse, but it changes the adjacent because now this is touching and this is the opposite side. So I say that because we have this Sohcahtoa, which several of you already mentioned that you've done in physics, so that's good that you recognize this. We have a sine function, a cosine function, and a tangent function. And apparently we're going to be Indian right now. And we're going to call this Sohcahtoa. It is important that you pronounce that correctly, because if you say Sohcahtoa, you're going to think that this is an A, and A stands for adjacent. So you wouldn't want adjacent hypotenuse, that would be wrong. So it's Sohcahtoa. So right now we're all going to say together. Sohcahtoa. Awesome. Brett is excited. So for sine, basically the Sohcahtoa is just a nice way to help you remember which sides go with which function. So for the sine function, it's always opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So we will move on here. Well, we'll try to. There we go. And my first example is going to ask you to write the tangent, sine, and cosine ratios for angle T and angle U. So first up, we're going to do angle T. Okay, so here's angle T. So in this case, we don't have a theta, but our focus is on angle T. So when I think about angle T, I want the tangent of T. Okay? And so since tangent is the toa, it's the Sohcahtoa part, the toa is opposite over adjacent. A ratio is a fraction. So we want opposite over the adjacent side. And if we use our focus as T, the opposite side would be way over there. It would be 3. And the adjacent side would be 4. Okay, not 5 because 5 is the hypotenuse. Very good. So also we want to find the sine of T and the cosine of T. So we're going to do all 3 of them. So sine of T would be for us to do the so part, right? That would be O, so opposite, and then the H is kind of silent. But sine is opposite over hypotenuse. So if T is my focus, the opposite side is still 3. But the hypotenuse now is 5. And we get 3/5. So the tangent T ratio is 3/4. The sine T ratio is 3/5. And then I can do cosine of T now. We need cosine T. And by the way, we do abbreviate tangent, sine, and cosine, but never call them tan, sin, and cos, because I will smack you. It is tangent, sine, cosine. So you abbreviate the spelling, but never abbreviate the actual name of the function. Okay, so cosine T is adjacent over hypotenuse. And the adjacent side, if T is my focus, the adjacent side, the one that's touching it, is 4. So, and then the hypotenuse is 5. Okay? So I don't know if it's confusing you when I say that it's touching, because technically to make this angle, there are 2 sides that are touching, but one of those sides is automatically the hypotenuse. So that's why I don't consider the hypotenuse, an option. So then this is the only side that could be adjacent. And then this side is totally not touching the t at all. So that's why that would be the opposite side. Okay, now we want to do this again, but now our focus is going to be u. So now I want to do tangent u. We want to do sine u and cosine u. And they're not going to be the same as tangent t, sine t, and cosine t because it's a different focus. So this time I'm going to be using u as my focus. So as I look at that, I want, again, tangent is opposite over adjacent. So opposite of u would be 4. And the adjacent side to u would be 3. So it's actually the reciprocal of tangent t. Okay, so sine u, again, same focus, we're focusing on u here. The opposite side is still 4, as it was in the tangent case, and the hypotenuse is 5. And then cosine, the adjacent side would be 3, and then 5. So you can see that when I changed focus, the sine and cosine switched, and then the tangents were like reciprocal. So they're not the same answer. So if you do that, and you don't change your focus, you can get the wrong answer. So don't do that. All right, so that's how you write the ratios. That's really easy to do. Just make sure that you're focusing on the right angle. And so right now, I want to help you with something because this is an example that I want you to do on your own. But before you can do it, you have to know what the hypotenuse is. In the previous example, I gave you all 3 lengths of the triangle. And in this case, I've only given you 2. So how are you going to write the sine and cosine? To write sine and cosine, you have to have the hypotenuse, right? And you don't have it. So you can use Pythagorean Theorem, and we can say that 3 squared plus 7 squared equals the hypotenuse squared, right? And to get that, I have to square root both sides. What is 3 squared?
9.
And what is 7 squared?
49.
And what's 49 plus 9? 58? Well, 49 plus 10 is 59, but it's 1 less than that, so 58. So square root of 58 equals hypotenuse. So it's kind of a weird number, but this is going to be square root 58. So now that you have that, you can continue the problem like normal and find the tangent, sine and cosine. You have 2 different angles, K and J, in this example. So you will finish that at home, and we will move on to the next thing. All right? What can you do with sine, cosine, and tangent? You can find missing links to the triangle, okay? For example, if I was trying to find W right now, one of the only things that you might think to do is to do Pythagorean Theorem. But you don't have enough information. You have too many variables because you would need 3 sides. And of the 3 sides, only one of them could be a variable. And you don't know what the hypotenuse is, and you don't know what this is, so you can't really do that. So we can actually use Sohcahtoa to help us find this, the answer to these problems. So what we're going to do is we're going to say, first of all, keep in mind which sides do you have. If this is the angle of focus, I have the opposite side is part of my diagram, the W, right? And I have the adjacent side. So which function uses the opposite and the adjacent side? Tangent. So you have to make a choice. Do I want to use tangent? Do I want to use sine? Do I want to use cosine? It depends on what information is given. In this case, we're going to use tangent because we have the opposite and the adjacent sides. So instead of the angle, it has no letter, but it does say 54 degrees. So I put tangent 54 degrees equals opposite over adjacent. Right? And now we want to solve for W. So I can multiply both sides by 10. And W is going to equal 10 times the tangent of 54 degrees. And it does say to round to the nearest tenth. And I do want to show you, you probably can't see the calculator this far away, but for those of you that are here, you want to go to your mode on your calculator. There's a button on your calculator called mode. Okay? It's at the very top next to your second button. And you want to go there because, for reasons that I can't explain right now, If you are not in degree mode, you will get the wrong answer. Let's just put it that way. If you are not in degree mode, you will get the wrong answer. And most of your calculators are probably in radian mode. So when you go to mode, you'll see the third option from the bottom, from the top, sorry. It says radian degree. How many of you have it in radian? Most of you probably have it in radian. So you need to move your little arrows to where it's highlighting the degree and change that by hitting enter on the degree. You have to be in degree mode. Yes?
What's the difference between radian and degree?
Oh, a lot.
Okay.
We'll get there, but right now just it's got to be in degree mode. So then we're going to go 10. Once you're in the right mode, you're just going to go 10 times tangent, which is again a button on your calculator, right around here, tangent, and then automatically a parenthesis will open, and then you type in the 54, close parenthesis, hit enter, and you get approximately 13.8. It's 13.76. We want to round to the nearest 10, so 13.8. So W is approximately 13.8. Any preguntas on how you do that? Primarily the calculator. Well, I can't really answer your questions right now, but you can ask them later. Okay, now we're going to do this again. If that wasn't enough explanation for you, we're going to come over here. Same idea. This time we have opposite side and we have hypotenuse side. So which function should I use?
Sine.
Sine. So I'm going to use sine 35, and that's opposite is x over the hypotenuse, which is 20. And so it's very similar, but we're using a different function. So we're going to go times 20 to get rid of the 20s. We cross those off, and x equals 20 times the sine of 35. Since we're already in degree mode, we don't have to change it again. But this time we're going to go 20, and instead of pushing the tangent button, we're going to push the sine button and put 35 in there. And we get, anybody?
1 point. No.
Not 1.
11.
11.5, right? Did you type it in right? 20 times, okay. 11.5, should have gotten 11.5. So this is roughly 11.5. And then the last one that we have is this guy, and here you have the adjacent, so the adjacent side and the hypotenuse side. So that function would be cosine. So we use cosine of 41 degrees is equal to the adjacent side, which is x, over the hypotenuse, which is 11, times 11 on both sides. And x equals 11 times cosine of 41. And what's 11 cosine of 41? 8.3?
Yeah.
So that is how you do this little guy. Any preguntas? Okay. Let me know when I can move this little screen. I know you guys are busily writing. The time is a-ticking. Are we good?
Yeah.
No? Okay. Right. Left. We should all sing a song, like the chamber people are singing songs, so we should sing a song. Are we good now? Should I? We good? Yeah? Okay. So then this is an example for y'all to do at home. Remember, figure out which function to use first.
We turn it in.
Go forth and prosper. I check your notes.
Oh.
So you will get credit for your notes.
So will this
Alright.
be on the internet?
Yes, it will be on YouTube.
Okay.
Find me, Cristy-Anna Martinez.
Subscribe.
Actually, just type in Cristy-Anna. Nobody really has that name. And you'll see my... Yes, you can subscribe to me. There's all kinds of videos up there. But... All right. So the last thing I want to show you is, so far we have always... I want to remind you, kind of show you what the difference is here. In these examples, and even in these examples, the variable was always a side. X is a side, X is a side, W is a side. Okay? You look at the next do-it-yourself, and X is a side, X is a side, W is a side, W is a side. So in these cases, you've always had the variable be a side. We're going to now go into what happens when you have the variable is not a side. See, it's like, all right? Or this example, okay, which I know all the sides already. So what are the angle measures? Dun, dun, dun. We don't know, right? Well, I'm going to show you. But first, we have to go to this. Remember, function notation. I said it earlier, sine, cosine, and tangent are all functions of x, okay? So I want to just remind you how function notation works, okay? We have a function, we call it f, because the f is just the name. A different function has a different name, we call it g. If I say f of negative 2, do I put the negative 2 in the g function?
No.
No. Where do I put the negative 2? You plug it into the f function, right? So I would get something like 3 times x is negative 2, and this would be 3 times 3, right? You guys know what I mean?
Yeah.
So this would be negative 6 plus 2, which is negative quattro. 3 times 3 is 9. 9 plus 2 is 11, right? G of negative 1 means I'm going to put, hello, Alex, negative 1 into the function here. I think Alex is obsessed with math. But okay. Negative 1 squared is positive 1. Negative 4 squared is positive 16. We're not going to be doing function notation for like our lesson today, but it is very important that you understand function notation, because when you guys see things like tangent t, it's really frustrating to me when I say something like, well, I'll just move the screen. See, tangent, sine, and cosine are functions. So you know how before you had an f, it said f of x? Now you have tangent of x. So what are the x's doing? The x is going inside of the tangent function. Now the reason why students have a hard time with this is because you don't know what the tangent is doing. When you look at regular function notation, you know what the function is doing. The function is taking the number, timesing it by 3, and adding 2 to it. This function machine is taking the number and squaring it. So you can see what's happening. It's very concrete. This guy, not so much. It's abstract. That's why you have a hard time. But I want to remind you that these work just like regular functions work. So this is not tangent times x. It's not like f of x is f times x, right? You would never do that. That's like lame. It's not f times x. It's f of x. F of x. The x goes into the function. So when you see tan x, the x goes into the tangent, into the sine, into the cosine. And the cosine gives you a number. Does that make sense? So when you went tangent 54, the 54 went into the tangent function, and it gave you whatever number it gave you. Does that make sense?
Mm-hmm.
Sky. Okay, so that's important because I say to you, I pose a question for you. Tangent x equals 1. Solve for x. The very first thing I get students to do is like, divide! Divide to my heart's content. First of all, tan is nothing more than what happens to you when you're in the sun for too long. Okay? Tan by itself is nothing. It has to have an x for it to be anything. Like it has to have a number or a letter or something there. Tan by itself is a word. It's not a math thing. So that's one issue, is that tan is nothing. So you can't divide by tan. It's like, what does that even mean? It's like the backwards of a tan? I don't even know, okay? It doesn't even work that way, okay? That's the first problem. Secondly, division is the opposite of multiplication. But you're not multiplying. I just said that. You're not multiplying. So you're not dividing, okay? You have to use this little thing called the inverse tangent. Because when two functions are inverse of each other, they cancel out. So what you're actually saying is tangent inverse. Tangent inverse, okay? And then the tangents cancel and you get x. But it doesn't cancel on this side, okay? So again, if that's still kind of enough for you, I can show you, later another little trick on how I can explain that to you, okay? But you need this inverse button. So on your calculator, when you look at the tangent button, right above it, if you hit the second button, you'll see what they call the arc tangent. You can spell it out, arc, tangent, or abbreviate tangent with the little -1. It's the inverse button, okay? That's what you have to use when this happens, okay? So, are we good? So here's an example. I'm going to show you how this works. In this example, they're asking me to find the measurement of angle x. Okay, I want measurement of angle x. This is my focus. I have all the three sides. So it doesn't matter which function I use. I could use tangent, sine, or cosine because I have all the sides. So, you takers, what do you want to use?
Sine.
Sine. Okay? So if I use sine of x, so I'm looking for the angle measure. So that angle is called x, so I'm going to call it sine x right now. And it's opposite, what's the opposite side?
6.
So that part is the same, the ratio is the same. Opposite side is 6, hypotenuse is 10. If you really want to, you can actually reduce that fraction because they're both even numbers, so it would be 3/5, right? 6 divided by 3, or sorry, by 2 is 3, and 10 divided by 2 is 5. Are we okay with that? What I'm telling you right now is that to get the x by itself, you don't divide by sine. You absolutely do not divide by sine. You get x is equal to the inverse of 3/5. And you write it like this because this is inside of the inverse sine function. It's inside of it. It's not like times it. You're not multiplying. So when you go to your calculator, you have to go second first, hit the sine button, and then again, a parenthesis will open up if you're doing this with me, and you put 3 divided by 5, close parenthesis, and you will get that x is approximately, I think it wants us to round to the nearest degree. So to the nearest degree is, if it's 36.8, it's going to be 37 degrees. So angle x is 37 degrees. Yeah? And we can find angle h as well. What about angle h? My focus has changed. But again, it doesn't matter which function I use. Let's not use sine because we already used sine. So should we use sine, cosine or tangent? What should we want to use? Cosine? So, cosine of h this time. So my focus is now h. I'm trying to figure out this angle. Now obviously we know that we could go 180 minus 90 minus 37, right? But I want to show you how you can do it with the trig functions. So if h is here, cosine is going to be adjacent, right? So adjacent is 6, hypotenuse is 10. So we get the same ratio, but a different function. So we're going to get different answers. So h is going to be the cosine inverse of 6/10 or 3/5, either way. And again, we're going to go to the calculator. We'll do second cosine this time, 6 divided by 10, and we get approximately 53.1 or 53 degrees. See? So the key that I want to make here, I said it earlier, when we are looking for the sides, are you guys done with that? I want to recap real quick, but I don't want to strip you away from your notes here. Are we good?
Yeah.
So I want to remind you, like when do you do which, okay? Back to this.
Oh, yeah.
In this case, we did not use inverse functions. Why? Because the variable was a side. Variable is a side. The difference is when the variable is an angle. If the variable is an angle, so the x is an angle, h is an angle, if the variable is an angle, then now you have to use inverse functions to solve for it. Does that make sense? Okay, so then here's your last do-it-yourself. And again, I want you to find the measurement of angle P and the measurement of angle Y. And then you will have completed your notes for this lesson, and we will see you in class, well, next class period.
Monday.
Woo! And someone needs to push the little red flashing record button so that it can stop recording me. Thank you, thank you.